Hello, everybody. We're on lesson 4.3 homework. I hope you got the postulates and theorems and everything. And I'm not going to turn the camera so that you can see me. You're just going to hear my voice today. Well, tonight, getting you ready for tomorrow. So I hope you guys are doing well. We're hanging in there. Most of you have heard about Andrew, and if you have not, he had surgery, emergency surgery on Friday, and kind of scary. So, but he's okay now, and we're thankful for that. Still got a long road for recovery. So I'm staying at home, helping take care of him for now. All right, well, let's get back to geometry. I missed you guys, and let's see if we can help you, get some of these problems done. We got 4 through 12. This is the assignment that we're going to give you for today, 4 through 12, 15, and 16. And we're going to do a couple of these problems, and then we'll see how you get it. Hopefully, one of these, 15 and 16, I'm not sure which one we're going to do. We'll figure that out here in a little bit. They're both proofs, all right? And we can't skip over them. We got to do them, and you got to get good at them. They're hard. They're hard to think of. They're easy when I guide you through it, but when you're trying to do it, it gets more difficult. And so I apologize, but we got to do it. All right. So the first one we're going to look at in your book, it's on page 192, and we're going to look at number 10. Okay. So page 192. This is one of your homework problems. Number 10. Let me focus this in a little bit so you can see a little bit better. All right, this is the one that has the N, the picture of the N. So I'm going to just make a rough picture of the N. And it says, what value of x makes the vertical parts of the letter N parallel? Well, the vertical parts would be these parts. All right, and we've got an arrow that says that this is 5x right there. And then we've got an arrow which says that this is 2x plus 9. And that expression goes right there. Well, if those are parallel, then I think it says something about the converse of the theorem that if the alternate interior angles are congruent, then, I'm going to say if, then the lines are parallel. Okay, and so, all right, well, that means if we can show that these are congruent or set up an equation to find the value of x that makes that true, then we can conclude that the vertical lines of the N are. So really, I mean, with all that being said, okay, really all you got to do is clear your mind and think of, okay, what equation? So you got all kinds of noise. What equation? I can create this equation. The alternate interior angles are congruent. And these would be what we would consider the alternate interior angles because there are two lines right here and they're cut by a transversal. So let's solve that. We subtract 2x from both sides. Now we have 9 is equal to 3x, and we have x then is equal to 3. So the question says, what value of x makes the vertical parts of the letter N parallel? And the answer is 3. It's that simple. That's all you have to do for number 10. Okay, let's go to one of the proofs. We're going to work on that together. Let's go to number 16. Now I'm going to recreate. Let me get a fresh sheet of paper here because I don't know how long this is gonna take. Okay, so let's see. It says, write a 2-column proof of the converse of the corresponding angles theorem. Okay, so number 16. Let's recreate the picture. You can see the picture in the book. This is at the top of page 194. And, okay, so we've got this, and this. We've got 1, 3, and 2. And we've got L and M, and I'm sure this is T for the transversal, and it is. Okay, so that's what we got so far. Now, let's look at the given. It says, given over here that lines L and M are cut by a transversal T. And then it also says angle 1 is congruent to angle 2. Now, we're trying to prove the converse, so we can't use the theorem that we're trying to prove. So we can't say, oh, because corresponding angles are congruent, then the lines are parallel. Now, we know that's true, but we're proving it true, and so we can't use it in its own proof. That's kind of confusing, but that's what we mean. So we're trying to prove that these lines are parallel. So I'm going to go ahead and write, prove that L is parallel to M. That's what we're trying to prove. Okay, is everyone okay? That's the setup. Okay, so let's set up our proof. Statements. Reasons. Here we go. 1 is the given. Lines L and M are cut by a transversal T. I'm going to go ahead and put the other part, angle 1. Angle 1 is congruent to angle 2. Does that fit okay for you guys? Maybe just a little bit. There we go. Angle 1 is congruent to angle 2, and so we'll say all that is the given information. Okay, so now let's go to step 2. Now, this is kind of a step. Now, you see where it says it's congruent, but it doesn't say the measure of it. We're just going to say the measure of angle 1 is equal to the measure of angle 2. And our reason there is the definition of congruence. Remember how I told you before that congruence and equals are about the same? There's just a small difference. And so we're just going to say that they're equal. Now, when we look at this picture, what do we know about 1 and 3? Well, they are a linear pair. That means they're supplementary. Okay, and so we're going to say that angle 1 and angle 3 are supplementary. I'm going to abbreviate, but they're supplementary. And step 3, we already said that's a linear pair. They're linear pairs. Okay, so step 4. All right, so if they are supplementary, then we know that the measure of angle 1 plus the measure of angle 3 is equal to 180. And that's the definition of supplementary angles. Definition of sub angles. Again, I'll say that a little louder. That's the definition of supplementary angles. And say, so as soon as we say that they are supplementary, then we know that because they're supplementary, they add up to be 180. All right. Now, we already know that 1 is equal to 2. And so we know that 1 and 3. So if we say now that we can substitute 2 in for 1 because they're equal, watch this, the measure of angle 2 plus the measure of angle 3 is equal to 180. And hopefully you guys see that that's a substitution step. Substitution property. Substitution property of equality. Okay, and then if that's the case, then we know if they add up to be 180, then we know that that angle 1 and angle 3 were supplementary there. And now we can say that angle 2 and angle 3 are supplementary. And guess why? Same reason, definition of supplementary angles. Because we've just shown that they add up to be 180. All right, now if we know that 1 and 2 are supplementary, what kind of angles are those? Those are same side interior angles. And we know that by the theorem that says the converse of the same side interior angle postulate, if those two angles are supplementary, then we know that these lines are parallel. So that's what we're going to do as our 7th and final step. That line L is parallel to line M because the converse of the same side interior angle postulate. I think it's a postulate. That's an angle symbol, so let me mark that out. I'll write it out. Angle postulate. All right, there it is. That's problem number 16. And so, make sure you do it on your homework, and I'll post this on Canvas so you can work on the rest of the time. You've got to work on your homework. All right, miss you guys. Hope you guys are doing well, and